Hello everyone, welcome to the first remote field day for Field Plot Techniques. Today we are at the Plant Science Research and Education Unit where we are going to be serving some of the field equipment that we use normally during field trials. Today we have Buck Nelson, a research coordinator at the Plant Science Research and Education Center, and Dr. Ken Quensberry, an emeritus professor in the agronomy department, and a former foliage breeder as well in our department. With that, Bob will introduce the Plant Science Research and Education Unit, and then we will go over some of the equipment that we use normally in our operations.
Well, thank you, Dr. Rios. Dr. Rios said, my name is Buck Nelson. I'm a research coordinator here at the Plant Science Research Unit in Citra, Florida. Just a little bit of background on this location. We're about 22 miles south of Gainesville. We're just under 1,100 acre research farm. We grow anything possible. We got a number of different soil types from like a sandy loam all the way to deep sands. So we have row crops. We have forages like Dr. Rios' research with the Bermuda grass, alfalfa, cowpeas and clovers. We got a lot of horticultural crops from tomatoes to peppers to sweet corn and such. We have a lot of blueberry breeding work, peach breeding work. So we do an array of stuff out here. This facility, this property was donated to the university back in the mid-70s by a local family, the Bedford family. It was all beef cattle research up until the mid-90s. From there, it was transformed into a location where faculty from Gainesville, as some of the research farms up there were condensing, they were wanting to have a facility where the faculty could come, didn't have to worry about borrowing a tractor, borrowing a planter, disc, and stuff like that. They wanted to come to a facility where it was maintained and they can just concentrate on the research, and that's how the Plant Science Unit came about. So I think 2001, 2002 was the first research plots put in here with maybe just a handful of faculty, maybe 4 or 5 faculty with 20 plots or so. Today we're up to 100 to 120 faculty. It varies between seasons, and at any one time we can have up to, let's say, 400 acres in research plots, but that varies from season to season. So it's quite a bit going on out here, a lot of stuff. I manage all the research, everything but turf grass, greenhouses, and ornamentals. I manage from the hort science to agronomy, soil and water science. We've even done a lot of work out here with, we got some aviation work with drones and stuff as well that come on site to do work. That's a little bit of background about us. Kind of turn over to Dr. Quensberry, and him and I will go through the planters and talk about how they're used in a research setting compared to a commercial use in them. So, Dr. Quensberry.
Hello and welcome. I think the thing that we want to convey to you most of all about research plot work is that the objective is always to simulate as close as possible what will be going on in a real world, large-scale field operation, but do that in small plots that are often somewhere from 20 to maybe 50 square feet. And in many of those cases, those individual treatments within an experiment may involve a different genotype, a different fertility regime, a different row spacing, something like that. And so the necessity of the equipment is that it has to be very flexible, and one must be able to oftentimes clean out the seed between one plot and then the adjacent plot. So those types of occurrences create the need for very specialized plot equipment, and believe it or not, that specialized plot equipment often costs as much or more as large-scale field combines or planters or other cultivation equipment, just because of some of those characteristics that I've suggested. So we're going to start and show you several planters that would be used for agronomic crops, and some of the specific attributes of those planters that make them useful for field plot work. This first one here is designed, you see the rack on it here, that's designed to hold a box. It has lots of little envelopes with lots of different genotypes, probably something like peanut. And so the operator then would be sitting here, and as you move from one plot to another, would be dropping just an individual genotype. You'll notice several hoses on it. It's designed so that you can clean out between individual ones so that you don't get any genotype mixing between the different plots as you're moving across the field. Buck, tell them exactly what kind of planter this is.
All right, this is a Monosim brand air planter, vacuum planter they call it. It's a commercial brand that a commercial grower, but this is, like Dr. Quensberry said, set up for research purposes to plant those specific genotypes in small plot situations. So basically a company called Seed Research Equipment Solutions, they can modify these planters to set them up for research. And as Dr. Quensberry said, you know, planters like these are a lot more than basically a commercial planter. We've been pricing some of them out recently, and you're probably looking at $50,000 to $60,000, depending on what you put into the planters. So this one was set up specifically for peanuts and sweet corn is what we've been doing a lot of the work with, that type of breeding. So when the operator on the back right here has his specific envelopes, as Dr. Quensberry said, he would dump his either two different varieties down in this tube right here, and it would go down in here, and there's a plate in here. There's a vacuum system that's sucking air on the back side of the plate. So it's sucking the seed to that plate. So say they want to do a 20-foot plot. So it's set up so that seed that's going to go in there, and it's going to plant the exact seed. So they want it 4 inches apart. However they set it up, they set it up with the gears. There's some settings on the opposite side that you set your gears up. And of course you got your plates depending on what seed you're planting, whether it's peanuts or corn or whatever it may be. So that way it's planting it in the exact 4 inches in row spacing that you have. So when they get to the end of their plot, there's another vacuum hose that goes up, you're done, and it cleans out your tank. He was talking about the importance of cleaning out that specific genotype. So it's going to go to a tank up here and clean that out, because you don't want any of that next genotype getting into your next plot. So it sucks out into this tank right here, and then of course it can be emptied out back into the envelope or in another container to catch it. And so that's the basic process. And we've also modified it too, because we still want to treat these crops as a commercial grower. So we're going to use in furrow treatments, which means is we're going to be putting out either inoculums or insecticides or fungicides in furrow right at the planter. See, as the seed is dropping in, this is opening up. There's a disc coulter up front here that opens the furrow when the seed drops in, and these are little press wheels that are having it. And you can see we have a spray tank here which we can put our chemicals in, and it runs hoses right back to here. So it's before the furrow is filled in by these press wheels right here, and which pinches the soil together, which closes the furrow. You're putting your treatments in there as well. So that's what we had modified this for, that setup, so we can do it in between each treatment. Being if we're doing the peanuts or if we're doing some other crops, so we can do it either way. So it's a pretty neat. This is an older model one. Like I said, we priced out some new ones because we're looking at, we got to keep this one on. This one's on 36-inch row centers as well, and we could go to a 30-inch, but it's such a major ordeal to move it. That's why we're looking at potentially purchasing another one where we can do a 30-inch row research. So it depends on the crop. A lot of corn crops are on 30-inch. Most peanuts are too, but for research purposes, they go on 36-inch so they can do data collections and different evaluations of the crop, it's easier to look at the plants before they fill in and stuff like that, even though you have buffers in between your plots. Now I'm going to switch over to this other monosim. This is more of a commercial type. Most commercial growers are going to have a lot more planters on their toolbar. This is what I say toolbar. This is your toolbar right here. So you mount your planters on this bar and you can set them up. It just depends on the size of the operation. And if we're doing one, we use this in research purposes because we'll have some crops where depending on the type of research, they'll want to plant just one variety. And this one is set up on 18-inch row center. So from the center, this here, the center here is 18, and then 18 there. So we can either put all the same variety, or if they want to have two different varieties, and that's what we're just going to plant, we can just put a variety here, a variety here, a variety there. It doesn't matter. And we don't have to worry about cleaning out in between because that's all they're going to plant for whatever research they may be doing. But it's the same principle as far as when you have it hooked up to your PTO on your tractor, which is driving the air. This is the fan part. When I say an air planter, this is the air that's going to be sucking against, pulling air where it's going to hold that seed to that plate. So as that seed's being held to that plate, it's like, again, you set your gears. I was mentioning earlier on the other planter about setting gears. This is where you set everything to match your plate. Your plate may be at different, the holes in your plate will be at different spacings and stuff like that, but you just have to match everything up according to the charts that are in the manuals and such like that. But on this planter here, we don't have a clean out. Like this one had a clean out for the different types of seed. When we get done with this one, what we do is we can take we take these plates off right here, and that opens us up to the seed plate. So what we'll do is we'll take, and there's a little dump lever down there, which we open up. When we take it off, it dumps out the seed. But to get a thorough clean out before we put it up, we take a small handheld shop vac and we just suck all the seed out that gets trapped in there as well. So that's kind of the basics on the two different types of going to a research planter to more of a commercial standard type planter that's used.
But you will notice that this type of planter could be used. You could put the same genotype in all three boxes, plant several plots with that genotype, and then apply different fertility, pesticide, herbicide treatments on that same genotype. So there might be situations, circumstances where you'd want to do that. I think it's also important to note with 3 rows like this, you have, that gives you the what you always want to have in small plots is you want to have bordering. Okay, so you could, the middle row could actually be your sampling row and be bordered on each side, like that.
Okay, this particular planter that we have here, this is a typical no-till drill, meaning no-till you can plant into sod, grass, something like this situation. It's a Great Plains brand no-till drill, but everything you see on the back has been modified. There's another company that modified it, they put on a cone planter. So we were talking earlier about the different genotypes, same situation, but we're planting a lot closer on a row spacing. Anybody doesn't know much about a no-till drill, kind of the basics of it. Normal no-till drill, you got your seed hoppers up here. You can plant your larger seeded crops. Say you're planting rye or something into a sod or what have you. Or you got this smaller hopper box. You can plant your smaller seeded crops, maybe your clovers or Rios, alfalfa, something like that. You can put in there. Well, and you got your settings and everything. It's got gears on it and everything to set it. Just kind of little basics about it being no-till. You have a coulter right here, which would cut the sod, makes a little, you see how wide that coulter is, like that. So that's going to make the coulter setting right there. Then these, same as the principle as the other planters, you have these coulters right here. There's 2 of them. So they're coming behind that as it's split, and they're kind of opening a little furrow is what they're doing. So you see the seed tubes coming down here, which could drop right in there. But of course we have the tubes from the cone planter, as you see them coming down. They're coming down here right as well. So the seed is being dropped right as the furrow is being opened. And then you have the press wheels, which seals that furrow in. And you can set the depth of that. That's what this little knob here is. You can set the depth of how hard you want it to press down. Of course, the harder it presses down, a little bit deeper it may go. It just depends on your soil types and stuff like that. A lot of sandy soils, even though you're planting in the sod, can be a little bit softer than if you're on more of a clay type soil. So to kind of get back to the cone planter right here, so as it's being modified, the principle is the cone planter. Take, for instance, you want to plant 20-foot plot. Same principle, you have your seed envelopes up on that tray up there. You have your operator sitting in this seat right here. You're all set up, it's calibrated. This is where we calibrate it, how long we want our plots, whether we want them 15, 20 feet, whatsoever. A lot of times we may have to switch sprockets. There's an extra sprocket here. We may have to go smaller or larger. If we're going to go smaller plots, we got to put on a bigger sprocket because we want to slow down this cone right here, because the slower it goes, the slower it's going to be dropping that seed in there. So anyway, the person sitting up here is going to drop the seed in that tube. So you're set up for a plot. So Dr. Quensberry will demonstrate up there.
So you're going to dump a tube in here,
So
raise that, and the seed are going to go around this cone, hopefully evenly distributed, because that's spinning inside there. Because the objective is you want to get an equal amount of seed in each one of these, what are there, 8 rows across here?
there's 9 rows.
9 rows across here. So you want to get an equal amount of seed when you lift. So this fits tightly against the top of the cone until you release it, and then the seed goes spinning around the cone. And then it's distributed. There's a belt around this cone that's open right at one spot, and when the cone rotates to this spot, then the seed come out and drop. And there's a spinner here that's also equally distributing it between all the different tubes. You might notice that there's 2 bubbles here, leveling bubbles, and those leveling bubbles are such that when you drop the seed, it should fall equally around the cone. But
Yeah, that's correct. You want to make sure the planter is level for even distribution. Even ties into with the depth of the seed, because you'd be putting too much back pressure on it. Your seed may be going to one tube more side, then your seed gets planted too deep. If you're tilted too forward, then you're going to be not closing in the furrow, and you may have seed lying on top of the ground, not getting completely covered up. So it's very important that you have it leveled. And you can level it up at the front of the tractor, or where it's hooked up. There's what they call a top link where you can adjust it, the pitch of the planter. And of course you get that all set up before you do any plots. We always like to go, before we go into an actual plot, we do little tests out there to make sure we have everything set up before we actually put the research seed that's going in a plot. We all go on that, we'll have an area prepped on the outside. We'll make sure everything's set correctly before we actually go in a research plot. Just to point out too, we said there's 9 tubes. We got different, I call these like the udders. Like on a cow's got udders. Usually a cow's got 4 teats or whatever. But this has got 9. But if we just want to plant, say, 7 rows, we can change this udder and put 7. Or if we want to do 4, we can do 4 or 5. We got different ones that we can do that, just depending on what the researcher is looking to accomplish. Because if we're planting, I'll give for instance on a researcher, normally this is 5 foot wide. A lot of times you don't want to plant in the tire track because it could be, you got your soil compaction right there, so the seed's going to come up at a different rate than the ones that are actually behind the tractor, because you're not putting all that compaction down there. Your tractor track's putting that tire down. So what we did, we got one researcher where we'll use a 72-inch center to center tire tractor, and we're going to plant, we only plant 7 rows. So we're planting directly behind that tractor. He's getting the maximum amount that he wants for his plot, but we're getting even distribution of the seed coming up. So we're not having a variance in there, because you could run into a variance. And so in between each one, you're looking at about 7.5 inches in between each row spacing. So it all works out pretty well. We kind of, over the years, kind of tweak different things to find out what works best. There's always little situations we can improve upon, and that's one of the things we did in a research trial in the last few years, so which has worked out pretty well for us. I mean, the main thing that the person writing this is communication between that person sitting here and that tractor driver, because normally we have the field already flagged out, or what I call tracked off, so we know where we're coming to an end and where we're, because a lot of times in between these plots we'll have a buffer. The researcher will put in maybe a 6-foot buffer, just something to accommodate, because a lot of times we got to do what we call plot maintenance, where we don't want nothing around that plot, so we have to go in there with the tiller or whatever, and we want to be able to get our equipment in here and get around these plots and take care of them, keep the weeds and stuff out the best we can. So with that,
If I'd comment on those buffers can be very important, because the time that it takes from the time you drop the seed here until it's planted, if this tractor is moving forward, could be 2-3 feet of your plot. So you have to be coordinating with the driver so that you know when to lift, so that the seed starts at the beginning of the plot and is finished at the end of the plot.
Yeah, that's that communication. That's why I was saying before going into a research plot, if you have something set on the side, where you can work out that communication between the person operating this and the tractor driver, that way you get it. And a lot of times, what we'll do, like Dr. Quensberry was talking about, if that person that's tripping this, say they get 2 feet into the plot before their seed actually starts getting into the soil, that's going to put you 2 feet into your buffer. So to be consistent with that, most people, you'll go down this way and plant and come back this way and plant. Well, to kind of not have that issue where you're going to have your seed, say that person doesn't get the communication, they keep tripping it that way every time, which we've had. We've gone what we call deadhead. We'll plant the same direction every time. We'll go down to this end, pick up the planter, drive back around, and plant this way. That way, every time, if that person that's tripping it is still having that issue, it's going to be planted the same way. So then we just adjust the plots to the alley and so forth to make it all work out. So
Good point. Good point. So we've shown you a lot of planting equipment and some harvesting equipment for forages, and now we're back to looking at some harvesting equipment that would be working with row crops, either corn or wheat. The machine that I'm standing by is a Weinersteiger brand with a corn harvesting header on it. So you can see it's set up for 2-row harvest. And again, this machine is probably more expensive to purchase on the market than the standard commercial combine, which Buck is standing next to. But again, it's designed to harvest individual plots and do a total perfect clean out between plots, so that you can get a clean, genetically pure sample of each individual plot as you go through the field harvesting it. And I don't know if we need to say a lot more about the harvester other than it's got a nice air-conditioned cab on it.
It does, yeah. I mean, like Dr. Quensberry said, you're looking at a 1970-something model here. Basically, it's a 3-row head, which we use to kind of clean up some plots and stuff like that. Where we've gone to this newer style, you're looking at a machine probably $350,000 roughly. That came with a grain head on it, grain head combine. Of course, we had to buy the corn head combine, corn header separate, and so forth like that. But like Dr. Quensberry stated, it's all a lot more automated. Like you have your cleaner seed, pure seed, because you can do all this from the cab. Now you got the grain tank on the back like you do on the bigger combines, but this combine here, you can catch your weights, you can catch your moisture contents. You got the bagger in there, kind of what I showed you on the peanut combine, same setup basically, catches the bag in there. Has a buddy seat in there, so you can have the guy who's driving it, and you can have the graduate student or technician or faculty member sitting in there that's actually collecting the seed, because you need someone in there to be swapping the bags out. That's a big help, And then if you want to clean it out or whatever, it's got the clean outs in there. But what you do is then it cycles through and it sends it to our main grain tank. So whatever's needs to be in between each individual genotype plot, you send it to the main grain tank. And so it collects it all in that tank, and then once we're done, we dump that into a wagon, and then of course when we're done with everything else, we give it a final blowout, clean out, and all that stuff before it's put up for the season. So right now, like we harvested a little bit of corn with it. Then we're going to switch back to our grain head because I do have a sesame trial we're going to harvest probably sometime next month.
So the fun part of that is that this header right here is just removable. And so you take one that's designed for a 2-row, you can take that off and put a standard header on it that harvests small grains or sesame or soybean or any of those type crops like that, that has a sicklebar and a reel. So here we have another alternative for small plot forage harvesting. This is mounted on a Kubota small tractor, and it's a flail type harvester. Unfortunately for those of you who are seeing the video, you really can't see the flail. It's enclosed in here. It's nothing more than a swinging blades on a rotor that's cutting the forage. Then as the forage is cut, the force of that rotor spinning is dumping the forage into this fiberglass bin back here. Once you reach the end of the plot, you simply lift the lever, as Dr. Rios is showing, and the harvested sample drops on the ground. You move on to the next plot, and the crew that's behind you comes along, retrieves that sample into the bag. The one issue that we've had with this machine particularly is the force of that swinging blade tends to also pitch a little bit of sand in with the sample, and so we get some sand contamination, and we generally have to account for that with our dry matter samples.
Okay, right now we're at what we call a peanut digger inverter. For those that are familiar with peanuts, you know your peanuts are in the ground, growing in the ground, because we've had questions in the past, do peanuts grow on trees? No, they grow in the ground. But when the peanut's ready to harvest, depends on the varieties. They can be in the soil up to 120 days, some 104. Just depends on the varieties the grower's going to use. We do have research plots. We do have breeding work that goes on here. So like at the very first planter we showed you, that's what we use to plant the breeding plots there. So when it's time to dig those plots, we take this machine out here. I don't know if you can see up in here, there's these blades right here. Well, anyway, when the tractor lines up and he's carrying probably 2 rows at a time, he goes up under those peanuts that are in the soil. So it's lifting them up. You know, it's lifting them up. So right here, when you get back, and this is all PTO driven, there's a PTO shaft right here, which is going to be running all this right here. So what it's doing, it's picking up, you know, as it's lifting it up right here, this is your lifters, and this takes the vines, and basically it's going to flip them upside down. So it's going to come off the back end right here, and it's going to slide right off the back end, and it's got it taking 2 rows, you imagine you 2 rows at a time. This is set up for 36-inch row centers. So it's going to take and flip those vines upside down so the peanuts are like this. So they're sticking up. And what you want to do is normally we leave them in the field for 2 days. We want to dry those peanuts down as much as we can before they're actually combined. Because right next to me is more of a commercial type peanut combine. So let's just say we let them stay in the field where they're sticking up like this. We can come in, usually we use this combine for our cleanup combine. And what this is doing is it's going to come, I don't know if we need to switch or whatever with the camera on Marcello's. But what this right here, you come in with the big combine, and what you're doing is you're straddling that row where the nuts are all sticking up, okay? And then what this is doing, this header down here, it's going to be picking them all up. So when it goes into this machine right here, it's got where it's going to separate the vine and the peanut itself. So it's got shaker pans in there as it's going along. And anyway, as the peanuts are being separated, the vines and everything are shot out the back. They go out the back of the combine. Your peanuts are put into this big basket right here. So we've actually modified, I don't know if we want to look at a modification on the other one where we modified it for research purposes. So what we have right here, as the peanuts are being separated, like I said, the vines are going out the back. Okay, the peanuts are going to be down in here before they go up to the chute. And we just modified the chute. Instead of sending the peanuts to the bin, which we still can, we have this machine modified where the peanuts can come out here. It's all air forced. Coming out here, we have bags we can attach right here. So you're catching that plot. Say you got a 20-foot plot or whatever it may be. You're catching those peanuts in the bag right here. So what they'll do is they'll use these mesh type bags to catch the whole peanut and everything. Then whatever the plot number is, that person ties the tag with that associated with that plot number. Again, we have the buffer space in between because that's where you're usually sitting in the buffer with the combine before you go on to the next plot. So they throw the bag out on the ground. It's got the tag number on it. When we're finished, we come along with wagons, pick them up, and we also are equipped we have where we can dry it. We have some wagons that have basically a false bottom in it where you have heated forced air coming up through the bottom and it's dry. We put the peanuts on a dryer because we want to bring the moisture on down to the peanuts to 10% moisture or what have you, something like that. And once they bring them down to that moisture, they'll take those peanuts back and they'll process them. They'll usually run them through a sheller and then they'll put them up, separate them up, either put them in a cooler or get them prepped to plant for another crop, another season.
So with forage research, one oftentimes needs to make multiple harvests within a season. 40 years ago when I started, this machine that we have right here was probably the top of the line. This is nothing more than a small sicklebar mower that you can see here, designed to go through the plot, cut it. Dr. Rios can point out that there's some skids on it where you can adjust the height of which you're cutting. You simply mow the plot down. Someone comes behind you, rakes it up, and puts it in the bag, and that's the way you obtain your samples. The good part about this machine is that it creates very little air suction or anything else, and so you get very little contamination of sand or other material into your sample, and it's easy to take a whole plant sample if you're doing botanical separations for leaf and stem and those kinds of attributes of forage research. And I think we're going to stop now and go to look at the more modern version that's totally self-propelled. This one is self-propelled with an operator walking behind it.
Okay, now we're over at our drying building. Once the forages, say Dr. Rios's work is alfalfa and such, or we got corn seed or other plant material that's coming out from researchers' field, and they want to dry down to get dry weights on the plant material. We have 10 dryers here. We have 2 dryers that run on gas. Those are our high temperature dryers. And normally we keep those for 135 degrees Fahrenheit to 140 degrees Fahrenheit. Then we have 8 other dryers that are electric dryers, and they're in duals. So like where Dr. Rios is standing right here, dryers 6 and 7 is run on one thermostat, and then we have dryers 8 and 9 run on one thermostat. Just for instance, let's say I bring in a lot of corn material, that's brought in from the corn harvest that it's used for breeding work and such like that, and they want to dry it down. We usually keep the temperatures between 97 to 100 degrees Fahrenheit, and that's in order. You don't want to go over that because you could kill the germination on that corn seed. So it's very important on regulation on those. We do have all these dryers. We also have coolers here, which is in the next building over for seed and such like that. So we have like what we call the sensiphone on them. So there's alarms set. So when the temperature exceeds a certain threshold or goes below a certain threshold, it sends off an alarm, and then we're able to come try to assess it. If it's something that we can't fix internally, we have a company that comes out and services them. So once we do that, which is good to keep up with everything, the forage work, I want to say y'all keep your dryers set at what temperature? 120 degrees Fahrenheit to 125 degrees Fahrenheit roughly?
About that, yes.
Okay.
It's about 50, 55.
And then
degrees.
you keep them in there for
4 or 5 days.
4 or 5 days?
Yeah.
Okay. And
Yeah, the goal is to drop the moisture fast and have a high quality dried material that at the end we can conduct other studies later, as well as determining the dry matter content of that sample. After we dry the samples, we determine dry matter content of the sample, and then we proceed with grinding them to further characterize the nutritive value of the samples. That's something very important in forages as well as for other crops. So determine the chemical composition of the sample. So that's why we would like to, have a good drying capacity so we can drop the moisture fast while maintaining the quality of the sample for further determinations later.
okay, inside one of our dryers, I just want to show what internally it looks like. As you can see, we have a shelving system in here, so the faculty can bring in certain, their samples and stuff, and they all have them labeled. You see marks on the bag, that's the plot numbers and stuff like that. So it's marked with, that looks like Dr. Rao, who's in soil and water science, who brought in his fall tomato plants, and they're drying down. And like Dr. Rios stated about grinding them down, because he was doing fertility trials, nitrogen trials. So what they do is they grind the plant samples down where they can extract, I guess, to tell how much nitrogen may be still in the plants or what have you from there. We also have, when I asked the faculty, students to log what they put in here, because a lot of time, these samples, our space gets busy at certain times of the year, so we want to make sure the material's in for the time it needs to be and out. So we have a lot of faculty that are coming and going. So it's very important, because I can't always walk in here and open up bags and tell whose samples is what. So we ask that they're logged with an in, contact information, and a proposed out date. So that's what we got. Of course, you've got an outside thermostat, and then we have usually a thermostat hanging in here too, just to monitor the temperature as well.
So we're here in another recently planted turf grass experiment. This experiment happens to be new potential experimental breeding lines of seashore paspalum vaginatum. When we looked at this particular block of soil, it became quite evident that there was a marked gradient across the field in terms of the amount of clay in the soil from the north edge going to the south edge. We usually don't have to worry about clay in Florida soils, but if you can see, I can hold up and make a pellet of this that sticks together from the amount of clay that's in it. So this end of the field here is much heavier in clay content, and as we move toward the south end, it becomes much more sandy. So this is a randomized complete block of 3 replications and 21 entries. So in terms of laying out the field, if we have a gradient that runs north to south, then we would want to apply our blocks in the same fashion. So block 1 on the north, block 2 in the middle, block 3 on the south, so that any variability associated with differences in soil would be associated with differences with block effects in the experimental design, and hopefully then all of the 21 entries get an equal chance to be in the heavier clay area, the medium clay area, and the more sandy area.
Exactly. So remember, always you want to put homogeneous experimental units within each block, and that means that all of the experimental units here, each one of these genotypes, are going to be exposed to similar environmental conditions. So don't think that the experimental unit is just the genotype. The experimental unit is the area where we impose the treatment, and all the management practices and data collection and so on will happen in this experimental unit. So if we impose that randomization restriction in each one of the blocks, and if we place the blocks in homogeneous areas, then we are going to be able to capture the variability between our treatments regardless of the environmental conditions where we have our experiment. Another thing to notice again is the marking, as we previously talked in other videos. Again, marking with flags versus marking with a tractor tire, and the amount of time that it requires. So you achieve the same outcome, which is basically you have really well centered plots, but again, the amount of effort that takes to mark the plots with flags versus with the tractor is also noticed. Again, whenever is what we're saying is important to mark the plots. This is basically a turf area where faculty from the agronomy department and the environmental horticulture department, they organize a turf grass field day, usually in October every year. So you will have people coming and looking at your plot. So that's why the importance of marking and centering your experiments so they can look pretty when you have a field day as well. And that is something that Dr. Walla will talk later, using some of your plots for research as well as for extension and other activities as well. And that is the importance of establishing your experiment in a good area, and also marking and centering your plots that will look great later down the road.
One of the things that Dr. Rios mentioned in the previous video was with these stoloniferous turf grasses, the importance of trying to keep the individual genotypes separated. Now, these plots have been planted exactly 1 week ago today, and you can already see from this here how the stolons are starting to run, and within another 2 to 3 weeks we're going to need to be cutting and maintaining these individual borders between the plants to keep the genotype separated.